Okay, Amit and Riley, who are watching this video, 5.3, this is what we're going to do today. Tomorrow, actually, section 5.3 is the middle of the chapter. But rather than giving you a mid-chapter quiz tomorrow, we're going to probably do some whiteboards or some type of review over the first 3 sections of this chapter. And then Wednesday, we start reviewing for your test. Wednesday, Thursday, Friday, we review for your test. This is the 8th period. You have your test on Monday of next week. For some reason, evens, just wait. For some reason, evens are on Monday and odds are on Tuesday. So you have this, evens is on Monday. So Wednesday, Thursday, Friday of this week, we review for this test, okay? Here's how the review works and how the test works. Your test is comprehensive, which means it's everything that we've learned thus far. That sounds like a lot. Yes, this whole semester. Okay, so here's the deal. Wednesday, Thursday, Friday, we spend time reviewing, and over those 3 days, I give you a packet that has 40 questions in it. 40 questions is all. That's not a whole lot to go over in 3 days, right? 40 questions, okay? And those questions are going to be the same questions as what's on the test, except not in the same order and different numbers, okay? Not terrible. You can use your review packet on your test, and you get 5 freebies. How that's going to work for the next couple days. Okay, good? 5.3 is the last section I'm going to teach you before we have semester tests. This stuff is fair game, though, on the semester test. You might have questions like this on the semester test. Okay? All right, but we won't test over chapter 5 until, like, January stuff, okay? When we come back in January, since 5.3 is the middle of the chapter, and the mid-chapter quiz would be next. I think what I'm going to do in January is I'm going to give you the mid-chapter quiz when we come back as an assignment just to kind of review, to refresh our brains, okay? So it'll just be an assignment, but it'll be like the mid-chapter quiz, right? What?
Is there going to be chapter 5 questions?
Yes, on the test. Like just 5.1, 5.2, 5.3. You want those on the test. Those are like adding functions together. You want those. Those are free points. Come on. We want those, right? Okay, so this section is inverse functions. Here we go. Last section. Make it a good one. Listen up. We'll go through this fast. Inverse functions. Here's what an inverse function is. These functions undo other functions. Okay, so 2 functions that are inverse functions undo one another. And I'll give you examples. We've seen these before. If we have x squared, what undoes an x squared?
Square root.
The square root of x, right? If we have an x squared and we're trying to get rid of it, we square root. These 2 functions are inverses, right? What's the inverse of the cubic root of x? What would be the inverse of him? X cubed, right? Those 2 things undo one another, right? So if I have one and I'm trying to get rid of it, I do the opposite one, right? These are called inverses. They undo their operation. Okay, that's what we're going to learn today. Okay, good? All right, now, aside from functions, if we have ordered pairs like A and B and C and all those good things like 1, 5, 2, 6, 3, 7, if I have ordered pairs, if I'm trying to undo them, like let's say I have 1, 5. 1, 5 is the ordered pair that I have and I'm trying to undo 1, 5. What do you think undoes 1, 5?
5, 1.
5, 1. 5, 1 undoes 1, 5. So what do? Flip them around, right? Okay, so let's go down here.
How do they undo each other?
They undo, and I'll show you in the graph. I'll show you in the graph, Josie, okay? So let's go ahead, and it says we have a triangle, and we're going to graph these points on this triangle, but we're also going to put this in this first table here. So like my first ordered pair is 1, -2. My second one is 2, 5, and my third one is 4, -1. Okay? Those are my 3 coordinate points. I don't know why there's an extra one. I don't know. So we have 3 coordinate points, and we're going to graph those guys over here. 1, -2, 2, 5, and 4, -1, and that's this triangle. This is triangle ABC, okay? And we just said that the inverse, to undo those things, you flip them around, okay? It like reverses it. It makes it go backwards. So this is -2, +1, like that, right? Instead of 1, -2, it's -2, 1. This guy would be 5, 2, and this guy would be -1, 4, right? We just flip them around. Okay, and let's see what the graph looks like after you graph him, okay? Negative 2 is at 1. 5 is at 2. Negative 1 is at 4. Graph those guys and we'll compare and we'll see what happens here. Okay.
It's like slanted to the left.
Yeah, kind of. Do you guys see a pattern?
Yeah.
Looks like it.
Okay.
It made a circle.
Rotate.
It kind of looks like it's rotated.
Looked like it
But
rotated.
really what's happened,
Did you just say it made a circle?
If you don't connect the dots, it looks like a circle.
yeah, it does kind of look like a circle. If
Oh,
you
wait,
can.
hold on.
Yeah,
Wait a
he's
minute.
saying if you
I
don't
messed
connect
up
lines.
my
Anyway, okay.
I did something.
All right, so that's what it looks like. Okay, here is what happens. And this happens to every single set of inverse points or inverse functions. Every single time you're dealing with inverses, this pattern will happen. Ready? Okay, there is an imaginary dotted line that goes from one diagonal corner to the other diagonal corner. Okay? And I'm going to draw it there. You draw it on your paper. And if you turn your head slightly to the right and put like that dotted line like straight up and down, do you see how it's flipped over top of that dotted line?
That's weird.
Do you see that?
Well, that's
It's like reflected over that dotted line. Like what's up here is now down here. What's down here is now up there, right? It's just flipped over top of it. That always happens every single time. Every single time. It's flipped over that line. Now, this is a linear function, right? What's the equation of that linear function? That dotted line. What? That's y equals x. Okay, that's superly important. Write that down on your paper. Y equals x is that dotted line that they're reflected over. Y equals x is that dotted line that they're reflected over. Yeah? Good? Okay? All right, let's go down now to this next thing. And rather than doing ordered pairs, it's easy to invert ordered pairs because you're just flipping them around. But when they give you an equation, it's a little bit harder to find the inverse, okay? So I have given you 4 steps of finding the inverse. And these are 4 basic steps, like they are not hard at all. 100%, they're pretty easy, okay? Steps for finding an inverse, okay? I'm going to write the steps up here, and then we'll go down and do that step to this function, okay? Step number 1. Okay, you take f of x, and you switch it to y, so you're really just renaming it. This is like a renaming step. Step number 1, f of x gets switched to y, all right? So if I do step number 1 to this function right here, step number 1, what's it look like? Y equals 2x minus 5. That's it. That's step number 1. Easy enough, right? Like that's really easy. Okay. Step number 2. The x and the y, I'm going to do like a double-sided arrow. They switch places with each other. Switch. X and the y switch places with each other. We haven't even done anything hard yet, right? X and y switch places with each other. Like you just call the x y and the y x. Okay, they switch places. So what does step number 2 look like for our function?
X equals 2y minus 5.
Beautiful. X equals 2y minus 5. Now, I have a lot of people, when they're finding the inverses, like to do step 1 and 2 at the same time. Because those weren't hard, right? You can switch them, and you can switch the x and y at the same time. Like, that's not hard. Okay? So if you want to do that, go for it. You can do step 1 and 2 at the same time. Step number 3, you solve for y. This is the longest of the 4 steps. Okay, this is like where the meat and potatoes are of your whole 5-course meal. This is like the big part, right? Solve for y. Okay, what does that mean to solve for y?
You just basically move everything over.
You get rid of everything except the y. Okay, so y is here. So what are you gonna move first?
2.
No.
Minus 5.
Oh, wait, plus 5.
Plus the 5. Okay, so if I add 5, what does that look like?
X plus 5 equals 2y.
X plus 5 equals 2y. Okay, then what?
Over 2.
Divide
Okay, divide by 2. Okay, I'm going to divide by 2, and I'm going to divide this by 2 and this by 2. When you divide by 2, everything gets divided by 2. All the way across. Everything's divided by 2. Everything's divided by 2. So I have y equals x over 2 plus 5 over 2. Okay? Now I'm going to flip it around, and I'm going to put my y back over here because I don't like them on the right side. I like them on the left side. And x over 2 is the same thing as 1 over 2x, right? I've just like taken the x and I slide it off to the side. Did you know that? X over 2 is the same thing as 1/2 x, right? Okay, so maybe write that off to the side over here. Like x over 2 equals 1/2 x. What about x over 5? What's that look like?
It'd be 1/5.
1/5 x. What about 2x over 3?
2/3 X.
2/3 x. You just slide the x off to the side, right? Okay, and you write that fraction, so that helps us a little bit. Plus 5 over 2 becomes, let's write it as a decimal. 2.5. 5 over 2 is 2.5. Okay, this is my function now. And now we have to do the fourth step. Step number 4.
Software.
Step number 4. No, we've done everything. Step number 4, the y switches back to his original name, except we can't call him f of x. We call him f inverse of x. And it looks like f to the -1 power. That is the f inverse. So we're just changing his name again, right? We're renaming him. If you want to put rename there, that's good. We're just renaming him again.
Wait, can you go back to those steps?
Okay,
3.
right there. Those steps. Just wait. We will. Okay, so that's the rename step, yeah? Okay, let's go back and rename him. So we have him. He is y equals 1/2 x plus 2.5. And now he is going to be f inverse of x equals 1/2 x plus 2.5. That's my final answer. Okay, that is the inverse. That is the inverse. Okay? All right, let's graph the guy in green, which is the original one. Okay, he is a linear function, right? So where do you start graphing him? -5, and then we go up 2 over 1, 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 down to left 1. There you go. He is a linear function. Okay, then we're going to graph the other one. And we're going to compare them. After we graph them, we're going to compare them. So the pink one, or the bottom one,
2.5.
you start at 2.5, so 2.5 is like right there in the middle, and then the slope is from there up 1 over 2, right? So we're at the half point, so we're going to go up 1 and over 2, and up 1 and over 2, and up 1 and over 2. And Reese Payne, you got to be paying attention to this instead of looking at your phone back there. And down 1 over 2, and down 1 over 2.
Where is the restroom? Yeah, I couldn't go to the restroom because there were 30 people.
Can you wait like 10 minutes?
Probably.
Okay.
My stomach is killing me, dude.
Okay.
Is my stomach growing?
All right.
Nobody's already grounded you.
All right.
It's very
Compare.
complicated.
Let's compare.
Terrible.
Let's compare. What do we see?
It's steeper.
It's like that.
The
It's
inverse
across
is
the line.
steeper.
It's across that magical dotted line. What's the name of that magical dotted line again?
X equals y.
Y equals x. It's always is it
different?
reflected across that line. Y equals
Same
x.
thing if it's flipped around.
What?
X equals y.
Yeah, basically. Yep. Y equals x, that line he's reflected over top of. Make sense? Good? Happy with that? That's the graph of him. Okay, let's go to the back. And now we're going to invert a different function. What kind of function? Y equals x is the name of that dotted line. Yeah, it's always flipped over y equals x. Okay? All right, now we're inverting what type of function here? What type of function is that? Quadratic. Oh, I heard you say quadratic. I heard somebody say quadratic. Parabola. Yes. So we're doing a parabola now, and now we're trying to invert a parabola. So let's see what this does. Step number 1. I'm going to do my steps up above here because we got a lot of room. Okay. Step number 1. What do we do first?
Change the f of x to y.
Change it to y. Y equals x squared plus 1. Step number 2.
Switch around y and x.
Y squared plus 1.
X equals y squared plus 1. Step number 3, we start solving, right? This is the hard part. So, minus the 1 over. So,
x minus 1 equals y squared.
x minus 1 equals y squared.
The square root.
Then we have to take the
Okay,
square root.
the square root and the square root. So y equals the square root of x minus 1. But we're missing something.
Plus or minus.
Plus and minus. We put the square root in there. Now, we're going to have to graph this eventually, and I'll show you what the plus and minus do on the square root function. I'll show you what the plus and minus does, okay? It's very important that you have that, all right? Now, let's do step number 4. And I'm going to flip him around. I'm going to switch the y and put him on the left side, but we're going to call him f inverse of x. And that equals plus and minus the square root of x minus 1. Does that make sense? This is my final function. Okay, that wasn't too hard, right? Just solving, we're just rearranging it, right? Okay, so let's graph the original guy, which is x squared plus 1.
starts
And
at
we
1.
said he looks like a parabola, right? He's going to look like a U, but what's the 1 do?
It puts it on 1 on the y-axis.
A 1 on the Y, so he's up 1, right? So this is up 1. All right, so we're going to start at 1. And if we go over 1, we would go up 1. If we go over 2, from there we would go up 4, right? Because we're squaring it, right? Over 1, up 1, over 2, up 4, right? And this is what my parabola is going to look like, something of this nature. That's the original guy. Okay, now we're going to graph the other dude. And I'm going to do it over here just so that we can practice. Do you know what the square root function does? What's the square root function look like when you graph it? It tips him sideways. The square root is just this guy, right? And he doesn't go back the other direction because you can't take the square root of a negative, right? You remember when we did that function matching? We did like the spoons card game, right? Square root. Okay, now, what does negative square root of x? Because we have a positive and we have a negative. These two together, right? What's the negative square root?
You can't do a negative square root.
He does this way. Now, you can't do a negative inside, but you can do the negative on the outside. The negative on the outside flips him down also. What?
Is it an S? No, it's not.
It's not an S. It makes a parabola, but on its side, right? If we didn't have the minus, we wouldn't have the other bottom half of the parabola. Does that make sense?
Yep.
Okay, so that's why we have to have plus and minus, all right? But then we have to decide, what's this minus 1 doing?
It
Puts
puts
down
it on
-1.
-1 on the x-axis.
Why?
-1 on the x side. I don't know.
This is where it's like the opposite of what you think.
Moving down one.
Nope, it's the opposite of what you think. It's the opposite of what you think. So it's on the x-axis, but it's going to the
1.
right one, right? The right should be positive. But since it's inside of the parentheses, it actually goes,
Negative.
yeah, it's I think -1 should be left, but it's actually to the right. Does that make sense? Right 1. So we're starting at 1. I don't remember what I said there. Okay, anyway. So to the right 1, we go over 1, up 1, over 4, up 2. He looks like this, something like that, right? Yeah. And then, look at our magical line. What's that magical line called again?
Parabola.
Y equals x. That y equals x line, did we just reflect him over? Don't look at my diagram. It doesn't look very good. But anyway, we just reflected him over, right? We just flipped him over. You need to turn your head sideways so you can see it. Okay, good?
Oh my goodness.
My purple one looks a little fatter than the yellow one, but that's okay.
Do you have
Whatever.
Put that line.
No, but I'm just I know at some point I do like a test question over it. So I want to make sure that you know that that's the line. Y equals x. You flip him over. Good? Happy with that? Okay, we're going to skip the horizontal line test, and we're going to skip number 3. But we're going to go down to number 4. This is the last question. Okay, and this is the hardest part. So, if you haven't been listening so far, listen now. This is the hardest part. Maybe it's the hardest part. I don't know. Maybe it's the hardest, okay? We're going to combine what we were doing on Friday to what we're doing today with inverses, okay? So, they're giving me 2 functions, f of x and g of x, and they want me to tell whether they're inverse functions, okay? And there's a test that I can do to see if they're inverse functions or not. And so, what the test is to stick one of the functions inside of the other. So we do f composed of g of x, and then we do g composed of f of x. We're sticking the functions inside of one another. Do you remember doing this on Friday? F composed of g, g composed of f. We're going to refresh your brains right now. Okay, Isaac Mackin, don't doodle on your paper. Listen to this. F composed of g. I know exactly what you're doing. I'm not dumb. F composed of g of x. Which one is the inside function?
G of X.
G of x. He gets stuck inside of the
F of X.
f function. So we're going to plug him in right there. So the f function was 3x plus 9, right? And instead of doing 3x plus 9, we're going to stick that other stuff inside of there, which is 1/3 x minus 3. That's going in there.
1/2.
I know, it does kind of look like 1/2, but I have my line over top of it. There you go. Okay. All right, now what?
No, we just solved. We
Okay, let's distribute that. What's 1/3 of 3? 1. This is just x, right? 1x, okay? What's 3 times negative 3?
-9.
Negative 9 plus 9 equals?
And that crosses out.
Those cancel out, so that's just
X.
x. Okay, all right. Okay. G composed of f of x is taking the f function and sticking it inside of the g function. F is here. We're going to stick it into the g function. So, 1/3 x minus 3, but in place of that is going to go 3x plus 9. Yeah? We're sticking that f function into the g function.
And we just
Okay.
compute the 1/3.
A third of 3x is 1x, or just x, and a third of 9 is plus 3 minus 3, and that goes away, equals x. Okay, here's the rule. The rule is, if you do it one way and you do it the other way, and they both come out to be x, then they are inverses of each other.
Go to the right.
Okay, then they're inverses of each other. So this would be yes, they are inverses. Now, it is not true that if they come out to be the same number, they're inverses. Like if one comes out to be 4 and the other one comes out to be 4. That's not necessarily true, right? If they both come out to be x, it has to be x every single time. Do you know why it has to be x? What's the name of the magical dotted line that they're reflected across? Y equals x, right? So when you plug them into each other, they come out to be x. And if they do, then they are inverses. Yeah? Okay, let's go down and check this one. So we're going to see if these two are inverses of each other. Here's f of x, here's g of x. Let's split it in half and let's do f composed of g of x. And let's do g composed of f of x.
Sounds like a mute.
Okay, so we're going to stick one into the other. So which one goes in first? Here. G is going into the f function. G goes into the f function. So what's that look like?
4.
4?
And then
2 square roots of x squared. Okay, now how do we square the 2 square roots of x? 2 squared is 4. What's the square root of x squared?
It's just gonna be
X. So this is 4 times 4x, right? Which is
8x.
16x.
which means what?
No.
Wait,
Which means I'm not going to do this side because one of them failed. So as long as one of them fails, the whole thing fails. So fail, not inverses, right? If one of them already fails, we're not going to do the other one. Make sense? They have to be x every time when you stick one into the other one. They will come out really nice. Everything will just like come out like butter. Good? Okay, go to your homework assignment. I cut some stuff off, so skills practice. You can skip 2, 4, 6 on skills practice.
So we have to do one.
1, 3, 5 on skills practice you have to do. And then evens on the bottom, 8, 10, 12. So odds on the top, evens on the bottom. I don't know why we did it that way. It's just the way it worked. 1, 3, 5, and then 8, 10, 12. Okay, on the back side, just the odds. 13, 15, 17, 19. Okay, 13, 15. That's not a long homework assignment. You can get a lot of it done.
At least
Okay.
we have to take graph it on the first part of skills practice.
Right. Yeah, not too bad. Okay, on the back is just the odds. Back is just the odds, okay? All right, get a good start.
And 19.
And, yep, 13, 15, 17, 19. Yes.
We have a question.
Okay?
Can we just
I'm gonna
write
stop
down
the video.
like this?